Okay, in this hour, we are gonna begin with high-order functions and the lambdas. I guess not many people have ever heard about high-order functions or lambda expressions. So what's high-order functions and what's lambda expressions? In Collins, functions are first class, meaning functions can be stored in variables and data structures, and functions can be passed as arguments to other functions, and they can also be returned from other higher order functions as well. Okay, so basically, what high order function means is that it's simply a function that takes functions as parameters or even returns a function. So that's what high order function means. Here's a good example of high order functions. And you can see we have a high order function here named fold. And don't be scared by this example because templates are involved in this example, but let's ignore the templates part. Okay, so let's simply focus on this high order function named fold. Okay, so you can see this function, this fold function takes two parameters. The first one is an initial value, and the second one is a function. Okay, so that's why this is, by definition, okay, from the previous slide, we know this function, the fold function, is a high order function. So what this function does is that it builds its return value by consecutively combining the current accumulated value with each collection element and replacing the accumulator, and then finally return the result. Okay, so this is an example of high order functions. Okay, again, this is because its second parameters over here is a function. So if you wanted to store a function inside a data structure or inside a variable, inevitably we're gonna have to deal with function types. Okay, so basically Kotlin uses a family of function types for declarations that deal with functions. So for example, here we have a variable named onClick, and its data type is these things after the colon. Okay, and every time you see parentheses, you know that this variable is a function holder. Okay, it can hold a function, and the function cannot take any parameters. Okay, because the parentheses inside the parentheses is empty. Okay, and this is the return data type for the function. Okay, that can be stored in this variable. Okay, and obviously because the return data type is a unit, this means the function stored in this onClick variable cannot return anything, okay, or returns nothing. Okay. So how do we instantiate a function type? And basically there are three ways. The first one is we can instantiate a function type by using lambda expression. The second one is using anonymous function. The third one is using a callable reference to an existing declaration of a function. Okay, since we have not formally introduced the syntax for lambda expression and anonymous function either, so let's use the third one as an example. Okay, so to instantiate a function type is very simple. Okay, suppose we have a variable named string plus over here, and you can see that this is its data type. Okay, so since we see parentheses over here, we know that this variable can hold functions. Okay, and those functions that can be stored in this variable must take two parameters. Okay, and both of the parameters are strings, and the functions need to return a string as well. Okay, so only those functions that satisfy this signature can be stored inside this variable. Okay, so how do we put a function inside this variable, it's very simple. We simply use the assignment operator over here, okay? So basically what this statement means is we are going to save the reference to this function into this variable, okay? And the function that the reference of the function that we're going to save in this variable is the plus function defined inside the string class. Okay, so once we have a function stored inside a variable, how can we invoke the function? Well, there are two different methods. The first one is to use the invoke method, okay? And then we pass in the parameters, very simple. And the second one is actually more natural way, I think. So we can simply use the variable as a function name, okay? So we can invoke the function stored inside the variable by simply saying, string plus parentheses, and then we pass in the parameters needed by the function. Okay, so the second way is the preferred way of invoking the function stored inside a variable. So, lambda expressions and anonymous functions are all function literals, okay? So meaning they are functions that are not declared, but passed immediately as an expression to a function as parameters. So you can see here, this is a very simple example. So this max function over here, you can see that its second parameter over here, this is an lambda expression, okay? This is an lambda expression, and this lambda expression is equivalent to this function, okay? And the full syntax of lambda expression is as follows. You can see that a lambda expression is always surrounded by curly braces, okay? So we have a pair of curly braces, and inside the curly braces, we have the parameter declarations, okay? And again, you can see that the parameter declarations follow the Pascal notation, meaning the parameter names and their data types are separated by a colon, and the parameters are separated by a comma, okay? And what follows the list of parameters is an arrow, okay? And after the arrow is the code body for the lambda expressions. So lambda expression can contain multiple lines of code, okay? So lambda expression doesn't necessarily have to be a single line of code. And one important thing to know or to memorize is that a lambda expression, the value of the return value, the value of the last statement inside the lambda expression is the return value for the lambda expression. Okay, so the return data type for a lambda is inferred, okay, and we cannot specify the return data type for a lambda expression because it is inferred, okay, again, because it is important, so I'm repeating again, the value of the last statement of a lambda expression is the return value for the lambda expression. Okay, so that's why we cannot specify the return data type for a lambda, and we don't have the freedom to return a value anywhere inside the lambda except for the last line. Okay, and we cannot use the return keyword. The value of the last statement determines the return value for the lambda expression. Okay, and this is the key difference between a lambda expression and anonymous function. Okay, now before introducing anonymous function, this is something what we call trailing lambdas. Okay, so in Kotlin, there's a convention. That is, if the last parameter of a function is a lambda expression, okay, then we can place the lambda, we can move the lambda expression, we can move the lambda expression outside the parentheses, okay? So here's a very simple example. Suppose we have a function called fold over here, and you can see that its second parameter, it's also the last parameter of the function, is in lambda, okay? And so we can, by the convention, we can move this lambda expression outside the parentheses, okay? So the code becomes this, okay? So this format is much neater and cleaner, right? Okay, so this is what we call the trailing lambda. If the last parameter of a function is in lambda expression, then we can move the lambda outside the right parenthesis. Okay, move the lambda after the right parenthesis. Okay. Um, um, Okay, so I have talked about this. So what this slide simply says is that, so one thing missing from the len expression syntax presented in the previous slide is the ability to specify the return type. Again, this is because the value of the last statement of a lambda expression is the return value for that lambda expression. Okay, so that's why we cannot specify the return type for a lambda, okay? And we don't have the freedom to return anything inside in lambda expression. So in contrast, if you need to return value, okay, somewhere inside a lambda expression, okay, then you should use anonymous function instead of a lambda, okay? So basically, an anonymous function is essentially a function without a name, okay? So the syntax exactly the same as regular function, except there is no name, okay? So here is an example of an anonymous function, okay? So we can see there's no name, okay? There's no name. And, okay. Before we move on to classes and inheritance, one last thing I wanted to mention is that a lambda expression or anonymous function can access its closure, okay? So what this means is that suppose this is the closure for a lambda expression or an anonymous function. So inside a lambda expression or anonymous function, we can access those variables defined outside the closure, outside the curly braces of the lambda expression or anonymous function. Okay, so this is what this statement means over here. Okay. Okay, so now let's move on to classes and then inheritance. So in Kotlin, classes are declared using the same keyword. In other words, class, and follow the class keyword is the class name, and then what follows the class name is the class body. Okay, and a class in Kotlin can have a primary constructor and one or more secondary constructors. Okay, notice that here a class can have only one primary constructor. Okay, although the primary constructor is optional, but it can only have only one primary constructor. Okay, and the syntax for primary constructor is very it may be odd, okay? Because, as shown on the slide, the primary constructor is actually a part of the class header, okay? Meaning the primary constructor goes after the class name. So as shown on the slide, the primary constructor for the class person is this one, okay? This is the primary constructor for the class person, okay? And if the primary constructor doesn't have any annotations or visibility modifiers, the constructor keyword can be omitted, okay, like this, okay? So one thing to note is that the primary constructor cannot contain any code. How strange is that, right? Okay, so again, the primary constructor in Kotlin cannot contain any code, okay? So the purpose of the primary constructor in Kotlin is only for initializing the properties of a class, okay? And the initialization code, because primary constructor cannot contain any code, the initialization code must be placed in an initializer block, okay, such as this one. Okay, this is the syntax for for an initializer block. Okay, um, so um, during an instance initialization, the initializer blocks are executed in the same order as they appear in the class body. Oh, by the way, I forgot to mention that inside the class, there can be multiple initializer block, or AKA init blocks, okay? And the order of execution of is exactly the same as they appear in the class body. Okay, and you might be wondering that why there cannot be any code inside the primary constructor, and why initialization can only be done within the init block. It's kind of hassle, right? Actually, there's a very simple or concise syntax for declaring properties and initializing them from the primary constructor. Okay, so say, suppose you wanted to define three properties, and suppose they are first name, last name, and age. And according to previous slides or earlier discussion, to initialize these three properties, we have to do it inside an init block, right? But equivalently, we can do the same thing using one line of code like this. Okay, so this means if we put val or var, okay, before the parameter name, the name of the parameters for the primary constructor, then the compiler is going to generate this piece of code. Okay, so these two things are equivalent, and obviously the one on the top is much more concise. Okay, so this is exactly what the primary constructor is for. Okay, it's for defining properties for a class and initializing the properties as well. That's the purpose of the main purpose of the primary constructor of a class inside in Kotlin. As mentioned earlier, a class can have one or more secondary constructors, and secondary constructors must be placed inside the curly braces of a class. And secondary constructors are prefixed with the constructor keyword over here, and which is followed by the list of parameters for the secondary constructors. And one thing to note that if your class has a primary constructor, then each secondary constructor needs to delegate to the primary constructor. And this is the syntax for delegating to the primary constructor, okay? You need to delegate either to the primary constructor or to another secondary constructor that delegates to the primary constructor. Okay, so keep this in mind. This is very important. Otherwise, your object won't be initialized properly, and your code may not even is not even able to compile, because the compiler is going to complain. Okay, and so you might be wondering what's the relationships between the primary constructor, the init blocks, and the secondary constructors. What's their order of execution? Well, essentially, the code in initializer blocks or init blocks effectively becomes part of the primary constructor. Okay, so that means the code in all init blocks and property initializers is executed before the body of all the secondary constructors. Okay, and if the class has no primary constructors, the delegation still happens implicitly, and the init blocks are still executed. Okay, so let me summarize a little bit. The order of execution is primary constructor, okay, and then the init blocks, and then the secondary constructors. Okay, so if your class doesn't have a primary constructor, then the execution order is the init blocks, which is followed by the secondary constructors. Okay, got it? Very simple. And similar to C++ and Java, if you didn't define constructors for your class, okay, neither primary constructor nor secondary constructors, the compiler is going to automatically generate a primary constructor without any arguments and with public visibility. Okay. So once a class is defined, how can we instantiate an object? Okay. Objects can be instantiated by calling the constructors, okay, either the primary constructor or the secondary constructor. So here's a very example. So here you can see we created a invoice object, okay, and obviously the constructor doesn't take any arguments or parameters. And this is how we, create a customer object, okay? And one thing to note over here, we don't need the new keyword in Kotlin, okay? This is the difference between Kotlin and Java, okay, and C++. So in addition to constructors, primary constructors, init blocks, and secondary constructors, what a class can have, okay? So in addition to those things mentioned earlier, a class can also have, of course, functions, okay, and properties, and it can also have nested and inner classes and object declarations, okay? So let's talk about these four things in the following slides. Okay, before that, let's talk about inheritance. Sorry, I forgot about inheritance. So as I mentioned in the previous hour, all classes in Kotlin have a common super class that is any, okay, any. So this means when you define a class such as shown above, okay, it will implicitly inherit the any class. So to declare an explicit supertype or to explicitly inherit some parent class, we simply place the base class after a colon in the class header, okay? So here's a very simple example. To inherit the base class over here, we simply put a colon, okay, right after the primary constructor, which is follow the name of the superclass or the parent class. And we also notice that we also invoke the parents, the constructor of the parent class over here, right over here inside the class header, okay? And another interesting thing is that all classes are final by default in Kotlin, okay? So what this means, all the classes in Kotlin, they cannot be inherited by other classes by default, okay? In case you wanted your class to be inheritable, okay, by other classes, then you must mark it with the open keyword, such as shown at the bottom of the slide, okay? Otherwise, no class can inherit from your class, okay? So this means everything must be explicitly stated, okay, in Kotlin. Excuse me. Okay, now when you inherit a parent class and suppose your class doesn't have a primary constructor, then each secondary constructor in your class has to initialize the base or the parent class using the super keyword, such as shown over here. Okay, this is very important, otherwise your object won't be able to be initialized properly. Okay, similarly, Kotlin requires explicit modifiers for overridable members, okay? So here's a very example. We have a open class named rectangle or rect over here. And we have another class named fill the rectangle. And obviously, fill the rectangle inherits from the rect class. Okay. And suppose we wanted to override the draw function defined inside the rectangle class, then we need to put the override keyword, okay, in front of the draw function inside the fill the rectangle class. Okay. Um, um, we can mark a member function final, okay, as shown on a slide. And if you mark a function as final, then it cannot be overridden by subclasses. Okay, so this is what the final keyword means. Um, the open keyword and override keyword also works the same way for properties. It's very simple. I'll simply leave it for you to read. So suppose you inherit from some parent class. How can we call a superclass implementation or a function defined in the superclass? Again, similar to C++ and Java, we use the super keyword. And we usually do this when we are overriding the function, okay? So again, using the same example, we have uh, a class representing rectangles, and we have another class representing filled rectangles, and the filled rectangles inherits from the rectangle class. And now you can see that, inside the draw function defined in the field rectangle, okay? And you can see this function overrides this one, okay? And to utilize the function defined inside the parent class, as mentioned on the slide, we can use the super dot notation, okay, to invoke the draw function defined in a rectangle class to draw the border for the rectangle first, okay? And once the border is drawn, we can then draw or fill the rectangle inside this function, inside this function, okay? So there's one last rule about overriding functions. That is, if a class inherits multiple implementations of the same member function, then it must override this member. But don't get me wrong. In Kotlin, there is no multiple inheritance. A class can only inherit from a single parent class. Okay, but then what does this mean? You might be wondering what does this statement mean? Well, although in Kotlin a class can only has a parent class, it can implement multiple interfaces. We'll talk about interfaces later. Okay, so here's an example. So here we have a class named square. And you can see that the square class inherits the rectangle class, okay? And inside the rectangle class, there is a draw function. And in addition to the rectangle class, you can see that the square class also implements the polygon interface. And unfortunately, there's also a draw function inside this polygon interface. So in this case, square, this class inherits multiple implementations of the same draw function, right? So in this case, we are forced to provide, or we are forced to override the draw function, okay? Otherwise, the compiler doesn't know which version of the draw function you would like to use, okay? So now let's move on to properties and the fields. So properties in Kotlin classes can be declared as, either as a mutable using a var keyword or as read-only using a val keyword. We have, talked about the differences between var and val right in the beginning in the previous hour, right? Okay. So, and another thing to note here is that all the properties in a class must be initialized inline or in the init block. Otherwise, the compiler is gonna, generates a lot of complaints to you. Um, to use a property of an object, simply refer to it by name using the dot notation. This is exactly the same as C++ and Java, so I'll skip it. So now, the full syntax for declaring a property in a class is this. This is kind of complicated, but don't be scared, okay? So this syntax simply means we can offer or we can define custom getter function and custom setter functions for a property or for a field inside a class. So when do we need to define a custom getter for a field? Well, in case the value for a property is calculated based on the value of other properties, okay, then this property is something we call a computed property, okay? And in such case, we can define a custom getter, okay, such as shown over here, okay? So in this example, we have a property called is empty, okay? And obviously, whether an object is empty depends on its size, another property, which is size, okay? So this is an example of a computed property, and you can see a custom getter functions is defined, okay, right beneath the property name, okay? So every time this property is empty, every time this property is referenced, its corresponding getter function is going to be invoked, okay? And inside the getter function, you can see its value is computed accordingly, okay? And similarly, we can also define a custom setter function using the same syntax, but a different keyword, that is set, okay? The keyword we use to define a custom setter function is set. And a setter function is called whenever its corresponding property is about to be written. Okay, a new value is about to be written into the property. Okay. Now, if you need to change the visibility of an accessor or to annotate it, but don't need to change the default implementation, you can define the accessor without defining its body like this. Okay, so the example, in the first example we see here, the stator visibility property has a private setter function. Okay, so this makes this property read only. Okay, only the object itself can modify its value. Okay, and all the others outside the object, have no right or the privilege to modify this the value for this property. And the second example over here, this is a little more advanced. Okay, so this annotation simply means a custom set function, setter function for this property is provided from outside the object. Okay, this is called the stator injection. Stator injection. Okay, I'm not going to talk about stator injection because that's a little more advanced, and we're not going to need this in this master anyway. But in case you're interested, you are always welcome to look it up online using Google by yourself. Now, in Kotlin, fields cannot be declared directly uh, uh, um, in Kotlin classes. However, when the property needs a backing field, Kotlin provides it automatically, and this backing field can be referenced in the accessors such as getter functions or setter functions using the field identifier. Okay, so this means what this means is that backing field is the place where data is really saved. Okay, and we can access the backing field using the field keyword inside our custom getter functions or setter functions. Okay, And of course, we can, if you don't like the backend field automatically generated by the compiler, you can, of course, create your own. Okay, so this is how we create a custom backend field. Okay, so you can see we have a map object. Okay, and its name is underline table. Okay. And you can see we have a property defined over here. Okay, this is a map property, right? In case you wanted to store the value for this property inside this field that you defined over here, then you can define a pair of getter and setter functions below this property like this. Okay, so this is how we define our custom backend field. So now let's move on to interfaces. Maybe you have already heard about interfaces before, but maybe you don't. But essentially, an interface is how an object interacts with the outside world. Okay, it's like the buttons on the front of your television, or the wheels. Uh, um, um, Inside a car. Okay, that's how people interact with a car, or how people interact with a television, so on and so forth. So in the most common form, an interface is simply a group of related methods with empty bodies. So for example, we can define an interface to specify the behavior of pets. Okay, for example, we can have the walk function, the run function, and the dance function inside the pet interface. Okay, this is how we define interface in Kotlin. Okay. And then you also notice that there's no implementation for these functions, okay, inside this interface. And to implement this interface, we can use the colon, okay, which is exactly the same as inheritance. Okay, so for example, to implement this interface, the pet interface on dogs, we can say class dog colon pet, okay. And similarly, we can implement the same interface on cat objects, okay, by saying class cat colon pet, okay. So once you declare that you are going to implement the interface, then you are going to have to override all the functions inside defined inside the interface. Okay, so you can see we need to all the functions defined in the pet function in the pet interfaces are overridden in a dog class, and similarly all the functions are also overridden inside the cat class. Okay. So the benefits of using interface is that we can do generic programming. Okay, so here's an example. We have a function over here called walk animal, and you can see it takes a pet. It takes a pet, and no matter it's a dog or a cat, we can always ask it. We can always ask the pet to walk, right? Right? Because both dog and cats implement the same interface, so we know no matter it's a dog or a cat, it is able to walk. Okay, because they both implement the interface. So this is new in Kotlin, object expression. So sometimes so before explaining what object expression is, let me explain the motivations behind it. So sometimes we need to create an object of a slight modification of some class without explicitly declaring a new subclass for it. And this is how Kotlin handles this case with object expressions and object declarations. So let me give you a brief example. Suppose you are programming in Java or some other object-oriented programming, okay? And suppose you wanted to register a mouse listener on a window object, okay? And you can see that to in this example, to register a mouse listener with an window object, we need to use this add mouse listener function, and this function takes a mouse adapter. Okay, it takes a mouse adapter, and mouse adapter is actually an interface, okay. So in order to register a mouse listener with a window object, in this case, if again this here we assume we are not programming in Kotlin, we're programming in Java or some other object-oriented programming languages, okay. So we are gonna have to define a class that implement the mouse adapter, and then we need to override all the functions defined in the mouse adapter interface, and then we create an object, okay, using the class defined over here, okay, and then finally we pass the object to the add a mouse listener function, okay, in order to register a mouse event listener with the window object, okay. So and you can see that's a lot of work over here. There's a lot of work, too much work involved for this simple purpose. Okay, so to solve this problem, in Kotlin, we can use object expression over here. So you can see in Kotlin, we can create an anonymous object right inside the parenthesis of the add mouse listener function, okay? And here we can say, hey, this anonymous function implements this, mouse adapter interface, okay. And then we can provide we can override the functions in the mouse adapter interface right up here, and then we are done, okay. So this code is much more concise, comparing to those on the previous slide, right? So this is an example of object expression, okay. This is also this example also explains why Collins such a syntax. Okay, I think this syntax is wonderful, and we're going to use this syntax. We're going to use object expressions a lot throughout the semester, especially registering event handlers for objects. Okay, another new thing in Kotlin is something we call companion object. Why do we need companion object, or what companion object is? Kotlin classes do not have static fields nor static method like we do in C++ and Java, okay? Instead, if you wanted to, or you need static fields or static methods, you're gonna have to use companion objects instead, okay? So this is the syntax. This is the syntax for companion objects in Kotlin, and everything inside the curly braces for a companion object, such as this one, they are static. Okay, that's a more that's an easier way to understand what the companion object is. Okay. So everything defined inside the companion objects, they are static, okay? Just keep that in mind. So now exceptions. All the exception clauses in Kotlin are descendants of a class Throttable. So how we handle exception in Kotlin is exactly the same as C++ and Java. So I will leave it for you to read. In case you don't know what exception is, then I guess you're gonna have to review the textbook for C++ or Java, okay? So now one last topic, and I think this is also one of the important topics for the first week, the second week actually, that is coroutine. So what is coroutine? Coroutine is basically a concurrency design pattern that we can use on Android to simplify code that executes asynchronously. So why do we need concurrency? Well, so let's take a look at this example. Don't be scared, okay? So you can see we have a function over here, okay? This function is called make login request. And you can see inside the function body, it makes a few function calls that involve, network operations, okay? And network operations can block the user interface, okay? Because transmissions over a network can cause delays, okay? So when waiting for a response from the server, uh, your app or the user interface of your app is going to be blocked, okay, unless you do this, unless you do this, okay, unless you call this function in a background thread, okay. So that's why we need concurrency. And traditionally, if you need concurrency, you're gonna have to create a thread by yourself, okay, and then you're gonna dispatch this function call to that background thread and deal with a lot of thread management stuff. Okay, so that's why Kotlin provides coroutine, okay, to simplify the work. Okay, so this is what we do to achieve concurrencies in Kotlin. So you can see to create a coroutine, we need a scope, okay? So the scope used in this example is called the view model scope. We're gonna explain what view model scope is later in the semester, but basically a scope defines the lifetime of a coroutine, okay? It's like, a variable defined, a variable defined inside a block, a code block. This variable is gonna be gone once your program exits, okay, this block, okay? So a coding scope is no difference. Okay, so this is you know how Kotlin manages the lifetime of coroutines. And now you can see the launch function over here. Launch is basically a function that creates a coroutine and dispatches the execution of the coroutine body to the corresponding dispatcher. And the dispatcher used in this example is dispatcher's IO. And this means that the coroutine is going to be executed on a thread reserved for IO operations. Okay. And that's it. Okay. And that's it. And then we can simply invoke the make login request function inside the coroutine, and it's not going to block your user interface, and your app can continue to interact with your with its user. Okay, it's a very simple. Although the previous example is already pretty good, but every time we call the make login request function, we need to remember to explicitly move the execution of the main thread or to a background thread, okay, like what we did over here in this example. So every time we need to invoke the make login request, we need to do this. Okay, we need to remember to do this. Okay, so one way to solve this problem, okay, we can make the make login request function as a suspending function, okay, by adding the suspend keyword, okay, in front of it. Okay, so every time you are gonna invoke a suspending function or a suspend function, the compiler is going to remind you that, hey, you need to invoke this function inside the coroutine. Okay, so you don't have to memorize, so this is gonna greatly reduces the probability that you forgot to invoke this function inside the coroutine and move its execution. to off the main thread to some background thread. Okay. All right. So I think that's enough for this week. Okay. Now, to let you have some hands-on experience, programming in Kotlin, I have two simple lab assignments over here. Okay, so these two lab assignments are created by Google. They are very simple Kotlin programming exercises. So please do these two exercises, and when you are done, copy your code and paste it to some text file or Word file, and then submit it to Moodle. Okay, you have a 1 week to complete these lab assignments. All right, so I will talk to you next time. Bye bye.